So hello everyone, welcome to YourPedia Education. So as we all know, ISRO shortlisted the list of candidates to whom they will be interviewing for the final stage, right? And ISRO is one of the best organization to start your career with, and one of the you can say best workplace to work with, right? And it's at the same time moment of prestige for each of the aspirant whosoever are shortlisted for the next stage. So from electronics and communication, how you need to prepare, what topic you must focus, and what kind of question they may ask you. So what I tried, I interacted with all my past students and I tried to basically record their interview experience as it is, not in the question form, in as it is way, how their interview went and how they were asked the question and what kind of cross questioning they asked. And I tried to collect question for analog electronics and communication. So that's what I'm sharing with you people today here. So if you are shortlisted for the ISRO, start your preparation with YourPedia Education. In YourPedia Education, it's the only platform where you get an opportunity to interact with the mentor and you can have one-on-one session, snap session and entire mock interview, which will be a real-time simulation exactly as replica of the final day interview, right? So let's start. So basically one of the students shared with me when he prepared for the interview, he was from the VLSI domain. So the first question asked to him was that which language you are familiar with. He told them C language and HDL, hardware descriptive language. They immediately asked him to write HDL code for 2-bit multiplier, and as he write the code or as he wrote the code, then they ask hardware descriptive language is equally efficient for both analog or digital design. This is just instantaneous questions. Is it clear? So like this they may ask you a lot of cross questioning. Then second question from the digital electronics, you need to prepare, you have the flip-flop, you have the latches. What is difference between the flip-flop and latches? And what are the different type of the triggering mode we can use in latch and flip-flop? There is positive trigger, negative trigger, there are so many other ways also, right? So that is what we are referring into. Then next question they ask about aliasing. Why aliasing occur? Can you tell us some practical example of aliasing and how can you remove and avoid it? I told them aliasing filter. Next they ask, can you draw the frequency spectrum of the anti-aliasing filter? So very good questions. Is it clear? So first they ask what is aliasing, how it occur practically, then you answered. Then they ask you, how you can remove it, then you suggest them filter. Then they ask the spectrum of that particular filter, right? Then what is difference between analog and digital filter, which is more effective and efficient in the noise environment? Very good question. If you are preparing signal system, if you are preparing communication system, then differentiation between the analog filter and digital filter is obvious question. You must prepare for it. So guys, these are the kind of question which you need to keep in mind while preparing for the ISRO interview. Next they ask, do you have any idea about the CMOS? He told, yes, I do have the idea about the CMOS. Then the next straightaway question will be, what are the application of CMOS? Can we use CMOS as a buffer? Can we use CMOS as an inverter? Can we use CMOS as an amplifier? If yes, then tell us how. You need to prove. And very common question from the CMOS is draw the transfer characteristics of the CMOS, right? Voltage transfer characteristics of the CMOS. On the y-axis you need to take the output and on the x-axis you need to take the input, right? So next question they ask, what is the Helmholtz equations? In Helmholtz equation you might be studied in the electromagnetic field theory. Then what are the curl, divergence and curl, but what are their physical significance? Mathematically you all might be knowing what is divergence, what is curl, what are their significance, right? So then magnetic vector potential and its physical significance. Magnetic vector potential, scalar potential, very renowned quantity in the electromagnetic field theory. See, mathematically it's very easy to calculate. Take the paper and pen. But do you know what is the physical significance? Why we are using curl? Why we are using divergence? Why we are using basically magnetic vector potential? What is the significance behind using it in the real engineering application? So these kind of questions they ask, and I am sure if you are prepared in the depth, answer for these all, right? So then they ask about design magic T. In microwave you discuss about the magic T. So how to design the magic T, and there is a one S parameter in the microwave frequencies or microwave devices. What is S parameter? How it is different from the electric parameter, Z parameter, Y parameter, T parameter and H parameter? What is the difference? And they may ask you that, okay, so can you calculate a specific S parameter for the given microwave device? So that all you must know. Okay, so next they ask, what is load line and what is difference between the DC load line and AC load line. You know, when we talk about the analog circuit, so there may be DC supply and there may be signal superposition of the DC supply. So circuit may be containing only DC, that is the DC circuit. Circuit may be containing both DC and AC. It means it contains both signal source as well as the supply source. So there comes the concept of the DC load line and AC load line. How you signify, what is the difference, what are their significance, that is very, very important, right? So then they ask, what do you understand by the power supply and what are the different component of the power supply. I always suggest student, if you are a basic electrical electronics engineer, so you must know what are the different stages of the design of the power supply. You must be very clear what is transformer use, what is diode use, what are the filter use, and what other device you can use. Okay, there may be a lot of questions related to this. Next question was this. You know, they ask you to calculate the output impedance of this given circuit. This was grounded. The difference was only कि open loop gain was finite, it was not infinite, and then they ask you to calculate the output impedance. I'm sure if you know, you can convert this operational amplifier into the, you know, equivalent circuit and then apply that Thevenin theorem, you can calculate its output impedance. It's very simple to calculate. See, ideally it must be 0, but practically it's not 0. Ideally input resistance must be infinite, but practically it may not be infinite. So they may ask you situation, okay, this is the open loop gain. Now calculate under this condition. So if they are giving a finite open loop gain, then you can't assume the ideal assumption. Then you need to go and solve the circuit as per their equivalent diagram, right? So next, going ahead, they ask you draw the input and output characteristics of the BJT, and as I did immediately, next they ask if we connect two diode back to back, so will they work as a BJT? So obviously, you know, when we talk about the NPN and PNP, so we have the 3 leads, 3 terminal, 2 junction, right? So for easiness, we assume 2 diode connected back to back. That is just an assumption, that is just an analogy, right? But actually, if you take 2 diodes from the market and connect them back to back, it's not going to solve the purpose which BJT do. It's not going to do the amplification, right? It may do the switching, but it will not do the amplification, it will not do the oscillation. So it means that is just an analogy to understand. Actually, that is not going to solve the purpose what BJT did basically. Next question, what are the region of BJT and application of the BJT? That's a very basic question. What are the analog and digital application of the BJT? I always suggest student, you must know the application of the BJT. Switching is the application, oscillation is the application, amplification is the application. These 3 applications are the biggest and best application and some of the top most wanted application of any device, be it BJT, be it MOSFET, be it operational amplifier. Switching, oscillation and amplification, right? Out of them, switching is the digital application, oscillation and amplification is the analog application, right? So next, going ahead, they ask draw the SR flip-flop using logic gate. Which logic gate be used to draw the SR flip-flop using edge triggered and level triggered? Is there any difference in working operation, truth table and identical for both? उसने बोला कि SR flip-flop को बनाइए, you may draw it by using NOR, you may draw it by NAND. So later they ask, you know, when you draw, is there any difference in the truth table or not? So guys, these kind of the mind blinking question they may ask you, so you must be prepared for them. Okay, so next you can see sampling again. What do you understand by the causal system and LTA system? If a sine wave input is applied to non-LTA system, what will be output? Will it be sinusoidal or not? See, we all know when we apply sine wave into LTI, output will be the same sine wave with same frequency. The only difference will be the amplitude and the additional phase. Now what happens when we apply into non-LTA system? That is a very good question. So they ask totally 180 degree apart what student used to study. So that is why they want to check your mindset instantaneously, how much capable you are of thinking, right? So next question, they ask how square wave can be generated. Then the student told them by using the analog device like operational amplifier in the multi-vibrator configuration. So they told, can we do the same by using the digital logic circuit? So then, you know, they asked to explain the op-amp and they gave the BJT also instead of the op-amp. They asked that design square wave by using the BJT instead of the op-amp, right? So next question is, have you studied about RC wave shaping circuit? What are the practical application of the RC wave shaping circuit in the digital electronics? Do you think diode can have digital application? If yes, then tell. See, you know, RC wave shaping plays very, very important role. RC can make a differentiator, RC can make an integrator, right? So in digital, you talk about the triggered impulse, right? Either positive triggered, either negative triggered. How to practically generate the triggered? So for that you need to use the differentiator circuit. Let us suppose you have a pulse wave, square wave. So at the rise pulse, at the false pulse, if you differentiate, you will get the impulse. That can be considered as a trigger practically, right? Ideally they may be impulse, but practically they are not impulse. They can be considered as a very infinitesimally small duration trigger. So that is the application. That is why they ask this question, right? So next they ask basically what is difference between the virtual ground and the virtual short. See, we talk always about the virtual ground. We always talk about the virtual short. We talk about the physical ground, physical shots. One is the physical, one is the virtual. What is difference? Why we are using the virtual world here? That is the very important. You must be in position to explain it, right? So next, they ask basically lot of question related to what is the importance of the source bypass capacitor. Is there any effect on the bandwidth the operating or not? Is there any other alternate that can be used instead of this? See, you use basically a emitter bypass capacitor in the BJT, source bypass capacitor in the MOSFET. They ask why we do this. If we are using this, is there any effect on the bandwidth? So usually on GAN we know all there is effect, but what is the effect on the bandwidth? Again, at the same time, there must be in your mind that GAN bandwidth product is always constant. If one thing is going to happen, other thing is also going to happen, because the product must be constant. So like this you can think also, or if you want to go analytical way, then you can also think, because when we talk about the frequency response, there is a higher frequency response, there is a lower frequency response. Higher frequency response is usually dominated by the internal or junction capacitances, and lower frequency response is dominated by these external capacitance, be it the coupling capacitor, be it the bypass capacitor, right? So you can think that way, GAN into bandwidth product is constant, right? So these kind of question. Then they ask, can you draw the source follower? So yes, obviously it's very easy to draw. You can draw it by using MOSFET. If it's a source follower, obviously by MOSFET, right? Then they ask, what is the voltage gain of the source follower? Obviously you will say, sir, it's 1. So then what is the question? Next question, can you guess why it's called an amplifier if its gain is 1? You can see the straight question. Is it amplifier? Do you really think that this will amplify? This will work as amplifier? You will say no. Then what are the application of this? Obviously there are not only the amplification application, or not only the voltage amplification, we have the other application, maybe power amplification, maybe current amplification, maybe impedance matching, maybe impedance transformer, perfect matching, so that we can maximize our transfer of the signals, right? So there are so many applications which comes into picture. So then they ask about feedback amplifier and what steps are used in designing of the feedback amplifier. Then entropy and conditional entropy, and I told you people what is difference between the noiseless channel and lossless channel, and how to calculate the information carrying capacity of the noiseless channel. What are match filter? Can we use match filter to reduce the effect of the noise? Very good question. Earlier we used to do some other kind of the integrator and something filter, right? But later it comes the match filter. So match filter is basically used to maximize the signal to noise ratio and decrease the probability of error. How it do basically by matching its impulse response in proportion to the incoming signal, so that we can maximize the energy at the output or signal power at the output, right? So then we have you can say other question, why audio amplifier is required in the communication receiver? Which is best receiver, super heterodyne or tuned radio frequency? So obviously you will say, sir, super heterodyne is the best over the tuned radio frequency. The very next question will be, what is image frequency? Don't you know that there is a loss, there is a problem with the super heterodyne, that is the image frequency? How to avoid it? So you must be prepared for this kind of question, right? So guys, these all kind of questions were there. So I suggest you people be prepared around this question. What I will be doing, this PDF I will be giving you people once you approach us, and you can read it. It contains more than 100 questions. They are either the mostly required questions or frequently asked question basis, or many of them are the previous year question. So guys, if you are preparing for ISRO, prepared with the mentors of YourPedia Education, you will get assistance in person, and you will get one-on-one interaction with the mentor, where you can attend your snap interview and the mock interview. I wish you all the best. Thank you.